Hi, this is just a little something I put together called a WPGA, Wi-Fi Programmable Gate Array. Years ago, I put something similar together for a Hamfest as a conversational piece between two telegraph units. The keyer would make sound on the opposite unit and vice versa. So, and I had to, when I did that, I wired it by hand. I programmed it by hand and everything, and it just, what I did since then is I've made a program to make that much easier. Each of these units basically it's an ESP. Let me get it in the camera here. It's an ESP32. The green light is connected to GPIO 12 and the red light is connected to GPIO 13 for demonstration purposes. Um, so when the units are connected, the middle one is not turned on yet, so it's why you only see two on the screen. But as soon as I turn on this middle one, uh, it gives it about 15 seconds or so before it propagates and makes itself aware. So there it is right there. And I can take this and I can move it around. And if you notice when I hover over each one, uh, it causes the red light to come on or throb on the units. That's just an easy identifier mechanism that I put in place. Uh, Position that just right, so that you can tell which unit you're actually connected to. So as far as that telegraph example, what we can do, if you look at the boot button is built into the ESP32 module. So when I press the boot button, you can see it go from 0 to 1, and I can do that with the next unit over here. I can do the same thing, 0 to 1, 0 to 1, and then this far unit over here, 0 to 1. See that one. This one's kind of a little been problematic. It doesn't want to come. It's kind of finicky. So there we go. I don't. That one's a little bit damaged, but it's okay. It'll work for this demo. So it's also a 0 or a 1 as well. So the cross-coupled communication that I did for the telegraph is basically really simple with this type of GUI that I put together. So if I want to connect from one to the other, the boot button I can connect over to GPIO 12, and then the boot button from this unit I can cross connect over to the GPIO 12 of the other unit. This is basically all I had set up for the telegraph. So now when I press the button on this unit, the light comes on the opposite unit. You can see the green light, which is on GPIO 12, and then vice versa on the other unit. Now I can do them simultaneously as well. They're independent of one another as far as the communication. And speaking of communication, it uses a mesh network that can support up to 1,000 nodes. It uses broadcast mode, and to identify each individual unit uniquely, it actually uses the Wi-Fi MAC address for each unit as an identifier. And that's part of what you see here. It's the last three of the 6 digits of the MAC ID. Um, so in efforts of this, what we can do is we can make this a little bit more complex. I've added logic gates to this as far as just instead of just a wiring up. That's kind of boring. But what I can do is I can let's remove these connections and then clear them. When I do the clear mappings, that basically, if there's any residual connections that were left, it'll clear those as well, just to be safe. So now when I press the button, it doesn't turn the light on the opposite side. So let's just make a simple latch circuit. So I want to click on this guy. When I click on this guy, I mean I can use the pull down right here that would actually pull the MAC addresses, but I've made it so that if you click on any one of these, it automatically uses that MAC address. Now when you do that, these are the logic gates that are applied to that particular device. Now each device has a maximum of 16 gates that you can configure. So right now what we want to do is we want to do an OR gate on this device. And let's see, I want to do it this way where the boot goes to here. And let's create an AND gate. Remember, we're making a latch. Whoops, I keep forgetting to do that. So drag that over. It got all the way to the far side here. There we go. We got two gates in there. Let's close. We only need one of them. So let's move that back over here. Okay, so now I want to flip this around. So now I want to make this connection to here and this connection to here. And now what we want to do is we want to basically enable the AND gate on here. We could either put a gate, we could still continue and put all of the gates on this one chip, or we could go over here and add a gate on this guy. Let's do a NOT and add a gate. See, I did it again. It's off the screen here. Okay, so we have a NOT gate. And so what we want to do is we want to take the output here, since it's a low, we want to make it high to basically enable the latch. Okay, so when the connection is high here, uh, it basically enables this latch. So when you set the boot high here, it keeps that. Now we don't have any indicators to indicate what's happening. So let's just make a simple feedback. This is the reset. So the boot button, when we press the boot button, the LED on that device itself will actually light up. But on this guy, we want to tap off of the OR gate. The output of the OR is basically the state of the latch, whether it's latched or not. So that would be a complete latch, or we can yeah, we can do that. That's fine. We won't use this one because, like I said, it's been kind of finicky. So this is basically complete. When I press this guy, that is the latch. So the green light comes on and stays on. Now, in order to make that light go, or that LED go off, we have to go over to this guy, and we press the boot button there. That's the reset, and you notice that the light went out. So that's basically we completely on the fly wired this up so that they incorporating logic gates and everything to this system. So, like I said, this is just kind of something that I'm playing with. There is a bit of encryption that goes on between the communications as far as how it's set up. It's not real fancy. I mean, it's just a CRC type of encryption. But what does make it allow you to have 1,000 nodes is that it sends the information in a differential update type of mode, like what you would do with hard drive updates and updating in differential mode. So because of that, the throughput is very minimal. It only sends what's changed. There is a check on the differential updates. So that if it doesn't match, there's a CRC that's sent with that. If it doesn't match, it'll attempt a few retries, and if it fails on like the 5th retry, what it'll do is it'll send the complete mapping of how everything's connected, which kind of defeats the purpose. But I mean, it doesn't have to. If everything's running smoothly, you don't have to worry about it doing that very often. It's just the incremental differential type updates. So you can literally have 1,000 nodes and still have a latency in like the tens of digits, if not single digits, as far as latency between response times. It doesn't have to rely on an existing Wi-Fi. It creates its own AP network in a mesh mode. So, like I said, this is just kind of something that I was playing with, and anyway, I thought I'd share. Thanks.